So let's look to this idea on some very simple problem that we call Grasshopper problem. So you have a line with n cells, and a grasshopper stays before this line. You know that grasshopper can jump for 1, 2, 3, or 4 cells, only forward, not back, only forward. Yeah, let it be like this. So, and then our goal to find the number of ways for jumping from the starting position to the, we can say that it is on the 0th cell, for example, yeah, to nth cell, that is the end of our line. And we can say that if n is 3, then answer is 4 number of ways. Because, so what is the, how we can jump? Okay, for example, if we have this line of size 3, the first way is jump 1, 1, 1. Yes. The second way is jump 1, then 2. The third way is to jump 2, then 1. And third way to jump directly to 3 cells forward. And you can see that 1, 2, and 2, 1 are different ways how to jump to nth cell. So we can see, we count all of these ways. So here the answer is 4. But how to compute answer for some arbitrary n? Okay. Okay. So for this reason, we remember that we use dynamic programming approach. So we try to solve big problem based on already solved the same problem but with smaller size. What can be size here of our problem? In fact, we have only one parameter, that is n. So if n is 1, just 1, 2, okay, 3, it is easy to solve the problem. But if n is big, 10, 20, 30, it is hard to solve the problem. That's why we can choose n as the size of our problem. So what is the problem? In fact, our problem is considering position number I and try to solve the problem. It is like how many ways to come to position I, to cell number I. Okay, let's look to all ways to come to position I. All these ways differs at least in the last jump. Okay, and it can be 1, 2, 3, or 4. We can split all ways to 4 groups. The first group ends with 1. Second group ends with 2. Third one with 3, and fourth with 4. So we can say that all these groups are different because at least the last jump is different. So each way comes to one of these groups and cannot be in 2 of these groups. But if we look to the first group, for example, before the coming to position I, what grasshopper should, where it should be? It should be on position I minus 1. So fi be number of ways to come to position I. So it is sum of number of ways from this for group. So if we come firstly to position I minus 1, then do one jump of size 1, we come to position I. So it is like if we take any way to come to position I-1, add add 1 to this way, then we obtain way to come to position I, and it ends with 1. And if we take any way to come to position I, and it ends with 1, then we just remove it and come to position I-1. So it means that number of these ways, it is exactly number of coming to position I-1. That is already stored in Fi-1. By the same way, we can understand that always always to come to position I such that the last jump is 2 is exactly Fi-2, because firstly we should come to position I-2 anyway, and then jump to our position I from this cell. And number of ways to come to position I-2 is exactly Fi-2 and so on. So we have this number of these ways in these groups are exactly these numbers. And totally the always is just sum of these four sizes of these four groups that are sum of four previously numbers. So you can see that it's very similar to Fibonacci numbers, but with some four previous numbers. So, but for cell number 1, 2, 3, and 4, we cannot use the same formula because just cells with indexes 0, -1, -2, -3 are not exist. And so these cells don't exist. That's why we cannot use this formula for these cells, and in fact we should compute it somehow. Yeah, it's called corner cases. So it is like some cells, some cases where we cannot use the same same way to solve the problem how we do it inside. These corner cases are very common idea for dynamic programming. Always we have corner case. We have always corner cases, for example, for recursion. We also have corner cases for our math induction. It is base of our induction, but it is also very common for nature. For example, we look to some cup of tea or water, and if we put some water here too much, then we have something like hill of water. But you see that in this middle, it is horizontal, it is just regular case, but here we have something like hill. And here also it is corner of our cup of our water, and it is different way. So it is common for nature to have starting is not like, or finishing is not like the intermediate situation. What we can do for this problem, we can just solve it by hands, but it is not very good. We can, because maybe we just, we can skip some way and can have mistake because this 8 ways is too much to compute it. So what we can do, we can try to solve it, compute it in other way. And anyway, for solving the whole problem, we need to take this Fn. It is result of our computation. Okay. So for our corner case, for our first four cells, what we can do, we can use the same formula but modified. So it is like for F4, it is in fact we can come from cell 3 to 1 or directly by one jump. Yeah, for 3 from 2, 1 and directly from one jump. And so in that case, it is much easier to solve, to write this program and but not to compute each number. Let's simplify this way also. So we can see that here on all this position is 1, but here should be F0 in fact. Yeah, that's why we can put as F0 1 and get the formula like this. So now we have common formula for F4 again. And we just put F0, 1, and then only 3 first cells by different way. Okay, but also we can write here plus 0, plus 0, plus 0. Yeah, and we can put F minus 1 as 0 because it should be here, and get the regular formula for F3. And only special formulas for F1 and F2. And so on, we can continue this process and obtain the regular formula for each of these cells, but adding the 1, 0, 0, 0 here. It is like we look to our cup of water. It was red one. Yeah. It was like this, but we put it inside bigger cup of water and add water. So let it be green water. And after that, we have these corner cases here. But in our main part that we are interested in, this part is already horizontal. So it is regular formula. But adding this bigger cap allow us to have easier corner case. So this one is much easier than computing 1, 2, 4, and 8. So, and also these values are very logical, so we cannot jump backward on the forward. That's why it should be 0, 0, 0. There is no way to jump to position -1, -2, -3, but also we already on position 0. It is like the one way how to come to position 0. And in fact, there are two ways, regular ways, how to solve this issue with corner. It is firstly solving in code, changing the code, have different code for corner case, and second way is solving by data. So it is like adding data to some specific data, easily computed data to our for our problem, and obtain the regular formula for each other positions. So okay, here we solve by data. And it is like we put these value zeros to 1, and but so typically we don't allow to use negative indexes. That's why we just move all indexes to 4 position forward. That's why the result is n plus 3, and we have such indexes. So we get such code. So this is for corner case, and also we just go by all positions and compute it in the last by sum of 4 last previous cells. Output fn plus 3. Okay, but what about time complexity and memory complexity? It is easy to see that time complexity is just linear because we have one linear for loop. But also the memory complexity is linear because we should have this array for storing the values. At the same time, we can reduce memory complexity because we see that we need only previous 4 values, not all n values, but only previous 4 values. What we can do, we can store them in 4 variables and just move this value. So like we have f current, f previous, so previous 1, 2, 3, 4. We compute the f current as a sum of 1, 2, 3, 4, and then move it. So it is like we have this f current, that is f1, 2, 3, 4. So we compute it by these 4 values. Yeah. Then we should have this new f current will be here. That's why this should be 1, 2, 3, 4. And we just move, for this reason, we move this value here. So firstly, this value here, and the previous one was removed, that erased. So we just move all of them here and obtain the new 1, 2, 3, 4 values. Okay, finally, we obtain the result with memory complexity m that is constant. We continue with the next problem in the next video. Thank you for watching us.